जी, हेलो इरफान। ओके। जी इरफान, आवाज राजी जमा था।
यस सर, आवाज
Oh,
कीजिए।
okay. Unfortunately, the internet a big issue da, and I was not sure chikkale the session end show. So that's so from where I should start again. Okay. So actually, I was telling you without going
Sir,
into the
please,
actual
sir,
details.
screen share कर दे please, sir.
Okay, okay, thank you. Just a minute. Is it visible now? अभी नजर आ रहा है आपको?
Yes, sir.
Yes, sir.
Okay. The basic idea behind the PC regression is simple. Let me just tell you again. PC regression actually says that if you discover after fitting the model and you discover that there are certain explanatory variables which are highly collinear, and if you cannot drop them, if you cannot increase the sample size, if you are not willing to go for a bias estimators using ridge regression, तो एक और तरीका ये है कि combine the information on the actual highly correlated variables, जिसको मैंने यहाँ पे शो किया है कि just imagine that these four variables in your model are highly collinear. They are highly correlated and they are actually causing multicollinearity. So the technique of PCA actually says, apply this technique so that you combine them in the form of one new variable, right? Denoted by suppose y1. And how y1 is defined? It is simply a weighted sum, जिसको हम बाद में कहेंगे linear combination. This is simply a weighted sum of the actual x variables, for which the general expression is a1x1 plus a2x2 plus a3x3 plus a4x4, where these weights, which will be constants, will be determined by the technique of PCA. When I will be doing PCA, then I will be able to tell you okay, how these weights are determined. For the time being, just take it for granted that this method would actually give you these constants, right? And once you know these constants, you can combine these four variables into one new variable. And then the idea is that in the original econometric model in which these four variables were appearing, replace them by this one new variable, which is what we call the PC, right? PC stands for principal component. Principal component is the name of this new variable, which results by combining information on the four original variables. So replace this newly defined variable y1, replace it instead of x1, x2, x3, x4, and when you fit the model, by replacing the highly collinear variables with the newly created variables that we call the PC, then such a regression is sometimes also called the principal component regression, the principal component regression, okay? So in the given case, if you want to, for example, if you have fitted this model in which weight and length were both there, and you don't want to drop weight or length, right? I think there is again going to be an internet issue. And you cannot increase the sample size, etc. So it actually says that, for example, if you go to statistics, oh, hello?
जी सर जी
जी अच्छा ठीक है, we are connected. I thought we have gone out of connection. So the basic idea is that, for example, if you don't want to drop these variables, or you cannot increase the sample size because you may be in such a stage in your research that you cannot just include more units into your data. So the idea would be to use a technique from the set of techniques that you call multivariate analysis, right? And those techniques are actually here. As you can see here, under statistics, when you come down to multivariate analysis, then you have a set of different statistical tools with different names, which come under the name of multivariate analysis. Multivariate means many variable analysis, right? And out of this, you have this particular portion that calls for factor and principal component analysis, right? Factor and principal component analysis. And if you just come over here, you would see there is something called principal component analysis, PCA, over here, right? So if I click this PCA, then I have to mention which variables I want to consider, which variables like x1, x2, x3, x4, which I was telling you. So if I just use the variable weight and length over here, right? Which means I want to run PCA, although for PCA, this would be a very small number of variables, but just the idea is you just put these two over there, okay? And okay, so for the time being, let me just leave all other things. If I click OK, just mention the two variables which you want to combine. Click OK. Okay, it will give you some output. Just forget about this output for the time being. And then you should just say predict and give it a name of y1, which means, okay. So these are actually the two weights, right, which I was talking about. The weights which will be assigned, in this case, equal weight is assigned to weight and length. And when I give the predict command, okay, as I'm telling you, just take all these things for granted. I'm not just particularly asking for you to exactly master these things for the time being, because this technique of PCA is something that we will study in detail in our next semester, because it will be part of the course that we call Advanced Quantitative Techniques. But what I'm doing by using the PCA, the command that I gave over here, you see, PCA followed by the variables which I want to combine. And then when I give the predict, and this y1, this is the name that I have given from my own side. So if I look at the data, at the end of the data, you will have a new variable created by the name of y1. This newly created variable y1 is the one that I was talking about here. Okay? When I was telling you that if these are the variables which are highly collinear, then PCA actually says, okay, why not just combine information rather than dropping any one of them, pool them together in the form of a new variable. This is like creating a new index, and this y1 would then in a sense represent all four of them together. So what we have done over here, the original variable weight and length, right? These two were actually highly collinear. So what we are doing, we are replacing them by y1. And the idea is, for example, if I just fit a model like this, reg price, and then followed by, let's say, y1. For the time being, if I just put y1 over here, in pure terminology, this type of regression in which I am regressing the dependent variable y on the newly created variable that we call PC, in strict sense, this particular regression that you see on the screen, this is then called the PC regression. Why it is called the PC regression? Because you are regressing the dependent variable on the newly created combined variable that we call y1. But you can also just fit a model like this, right? Sorry, this one. And over here, you can just remove the variable weight and length, and you can replace y1 over here. So you see, if you fit a model like this, then what you have done, all other variables are there except weight and length, because weight and length are actually replaced by the combined variable y1, right? And this is one particular remedy that is usually suggested for controlling the problem of multicollinearity. Okay, so PC regression का advantage actually ये है कि it overcomes the possible problems associated with the first three methods जो मैंने आपको कहा था. First method क्या था? Dropping. Second क्या था? Increasing the sample size. Third क्या था? Ridge regression. In a sense, if you can afford biased estimation, biased results, अगर आप कहते हैं कि in order to solve one problem, ये इस तरह है ना कि जिसको लाइट स्टाइल में वो कहते हैं कि for example, you are going to a doctor and the doctor says that, okay, I will give you a medicine which will cure your this particular problem, but there is a side effect of this particular medicine. And then the doctor explains what will be the side effect. And it says, okay, if you are ready, if this particular side effect is not a big problem for you, तो ये जो medicine मैं आपको suggest करता हूँ, it will actually cure your main problem. So by looking at the nature of the side effect, if you think that it's okay, I can just live my life with that particular side effect, like a small minor allergy or whatever. So you can say, okay, just give me the medicine, right? So ये ridge regression उस तरह है कि it cures the main problem of multicollinearity, but it will introduce biasness into your results. So if you can trade it for biasness, then you can go for that. But usually researchers say, no, I don't want to get biased results. So PC regression का सबसे बड़ा advantage ये है कि it does not tell you to drop anything. It does not say, okay, go back and increase the sample size. It does not say that settle for the biased results. It says just replace the actual variables, the actual highly collinear variables, by a new variable, which we call the PCs, the principal component, which in a sense combines information on the original variables and creates a new one. The only disadvantage is that this new variable y1, which is replacing, for example, weight and length, sometimes there would be interpretation issues. यानी weight तो एक original variable है ना, जिसको आप easily explain कर सकते हैं. Length is the original variable, but sometimes it will be difficult to give a proper name to this newly created variable. तो अगर आप इसको proper name नहीं दे सकते तो इसके results को interpret करना, like for example if you say 1121.558, right? So technically it says that for a unit increase in y1, the price of a car increases by $1121. But for example, when you say when y1 increases by 1 unit, so what is actually y1? So if you can give a proper name to y1, right, then interpretation becomes easier. Otherwise, sometimes there is a problem of interpretation associated with this newly created variable. So therefore, solutions available हैं, but not every solution is ideal. एक और solution भी ये है, अगर मैं आपको ये बताऊं, which is quite astonishing if you just look at the book of Gujarati. Gujarati, one of the solution is that you should do nothing, right? Because of many arguments, it says that because multicollinearity somehow is going to creep into your model, and because it is actually a sample problem, so sometimes if you cannot go for any other solution, so you can just leave your model as it is, which is not actually a very ideal sort of solution. But one of the argument, अगर आप यहाँ पे, I hope if you go to the details of the chapter, you can find it over there, okay? But PC regression by far is considered to be one of the most reasonable solution. How this PCA is actually performed and what is the main idea behind PCA, इसको फिलहाल मैं intentionally इसलिए explain नहीं कर रहा हूँ कि because we will go into the details, and there when we will be considering the PCA procedure, I will also tell you why this PCA procedure is so much important, because this PCA is a very important technique which is used for very important thing, और हो सकता है आप में से कुछ लोग इसको अपने research में भी use करें. It is actually indeed a technique for index construction, right? Index construction. If you want to construct an index, like asset index, like index of growth, like happiness index, etc., right? In fact, आजकल आपने सुना है ना कि the Transparency International has actually issued a list of the countries according to its corruption perception index. So when corruption perception index is constructed, this technique is also used over there, right? How it is used over there, this is something that we will discuss in detail. So PCA is a very useful technique, but basic idea is actually this one. It is applied on a number of variables, and the purpose is to bring data on a large number of variables into a smaller number of new variables. In some cases, just one new variable. In some other cases, 2 new variables, 3 new variables, right? So if you are dealing with 50 original variables, x1, x2, right, up to x, maybe x100. So you are dealing with 100 actual variables. So when you apply the PCA on that data, which consists of 100 variables, this may tell you that the information contained in 100 original variables may be combined in the form of just 2 new variables, y1 and y2, right? Or maybe y1, y2, and y3. So later on, we say that PCA is a very effective technique for reducing the dimension of the data. So rather than studying the 100 original variables, it may be sufficient to study only 3 new variables. And these 3 new variables will give you almost the same information as is given by the 100 original variables. But in case of multicollinearity, this is one way of using the PCA. ठीक है? I'm not sure whether you have got the actual idea, लेकिन ये थोड़ा सा उसका एक फ्लेवर है जो कि मैं आपको देना चाहता हूँ जी. Is it okay for the time being? Hello?
Yes, sir.
Right? Although I'm sure that because PCA technique is something जिसको हमने काफी डिटेल से डिस्कस करना है, but this is how you can do that thing. And the basic idea is, जिसका मैंने आपको यहाँ पे दिखाया, replace the highly collinear variable by the newly created variable y1. And what is y1? It is actually combining information on weight and length. So replacing weight and length by the new regressor y1, this is one way of not dropping the actual variables, rather combining them into something new. So this is one way of dealing with the problem of multicollinearity. ठीक है? Okay. Now let's go to what we call heteroscedasticity. Is everyone still here?
Yes, sir.
Right. Okay.
Sir.
So heteroscedasticity originally refers to one of the violations of the assumptions of classical linear regression model, right? If you recall those 10 assumptions of classical linear regression model, CLRM, one of the assumption was actually something like this. One of the assumption was saying that the variance of the disturbance term remains constant. It does not change, right? For different values of x, like for example, if you look at the structure, it is something like this. As income increases, if the variance, if y is, for example, our dependent variable, if it represents savings, and x is our explanatory variable income, then what we call homocydusicity, right? Non-changing variance, it assumes that as income increases, the variations in savings remain constant. What we mean by that? That the variations or differences in income, in savings at lower level of income and at higher levels of income remains the same, right? If this is the situation, then we call it homocydusicity. But if we have something like this, where you can see that the curve, the distributional curve is spreading out. When the curve is something like this, we say there is less variation. But as the curve spreads out, it shows more variation. So a more flatter curve shows more variation in data, and a more thinner curve shows less variation in data. So this particular structure actually says that as income increases, the variations in savings at different level of income is also changing. In this case, variations in saving is also increasing. Practically, it means that the constant variance assumption was actually assuming that if income increases, the variations in savings at any level of income will remain the same, चाहे वो lower level income है या upper level income. But violation of this assumption that we call heteroscedasticity actually says that no, as income increases, then the variations in savings, which is represented by variance, would also increase, which makes sense because you know that at lower level of income, people would have differences in their saving pattern, but because of the lower level of income, they would not be able to save that much. So therefore, there would not be that much differences in their saving pattern. But as income increases, we know from our observation that at higher level of income, you have more choices for the disposal of your income, and which means you have more choice to save. So therefore, the variations in saving pattern also increases, right? So therefore, it is very much possible that if you are considering relationship between savings as dependent variable and income as independent variable, it would be very unlikely that you would have a situation like this, right? Constant variance. It is very much likely that you would have a situation like that. So heteroscedasticity, which is the opposite of homocydusicity, refers to the situation where the variance of the disturbance term and ultimately the variance of the dependent variable uh, actually increases or decreases. It does not remain the same. One thing that I would like to quickly tell you so that थोड़ा सा आपको idea हो. Uh, Remember, there is a simple result in econometrics which says that variance of the dependent variable y and variance of the disturbance term, which in our discussion we have represented by u, right? Variance of the dependent variable y and variance of the disturbance term u, they are exactly one and the same thing. Under the homocydastic assumption, we know that the variance of the disturbance term, right? Variance of u is actually equal to expected value of, this is just a statistical formulation. I'm not actually in a sense emphasizing कि आप ये derivation याद रखें, लेकिन सिर्फ आपकी understanding के लिए मैं कर रहा हूँ. The variance of a random variable u is defined like this, okay? U minus expected value of u, right? This is something like this. The expected value means the average of this square difference. What is this square difference? This is difference from the mean. U is the random variable u, and expected value of u represents the mean of u. So u minus the mean of u whole square. If you take the average of such square differences, then this is what we call the variance. And because this reduces to expected value of u square. Why? Because since one of the assumptions of the classical linear regression model is actually telling us that expected value of u is actually 0. Okay? This is one of the basic assumption of the classical linear regression model, which says that the mean of the disturbance term is 0. So if you replace this portion, this one, by 0, what is left inside the bracket? only u is left and with the square outside, right? And this is actually, by constant variance assumption, we say that this is equal to sigma square. Okay? We are assuming that this variance of the disturbance term is equal to this one. So basically, the variance of the disturbance term is the same as expected value of u square. Now, on the same lines, variance of the dependent variable y, using the same definition that you have used for the disturbance term u, would be defined like this. Okay, it would be y minus expected value of y. This whole square. This is the basic definition from the probability theory. We say that for any random variable, the variance, if expected value of y represent the mean, right? If expected value of a random variable represent the mean, then expectation of this square difference is actually what we call the variance. Okay? And in the simple regression model for SLRM, if you consider the simple linear regression model for the purpose of just explanation, then we know that what is y, okay, and what is expected value of y, right? For SLRM, simple linear regression model, we know that we represent y as beta naught plus beta 1 x and plus u. If you are talking about multiple regression model, then you can just add x1, x2 and so on. So this is actually the simple linear regression model which says that y is equal to this one. Then what is expected value of y? What would be the mean? If you obtain the mean, then for expectation, beta naught is treated as constant, so it will be reproduced as it is. Beta 1 x is also treated as constant, so this will be actually used as it is. And expected value of u is 0 from here, right? So therefore, expected value of y is something like this. So if you put these two, y here and expected value of y here, so it would be this right hand side minus this right hand side. So what you will get here? It would be actually something like this, right? Y minus expected value of y, okay? Y minus expected value of y will give you what? It will give you the disturbance term u. Because this right hand side minus that right hand side will give you this disturbance term. So that's why. And what is this expected value of u square? It is equal to sigma square. This actually implies that variance of the dependent variable y and variance of the disturbance term u are one and the same thing. Okay? Why I have actually given you this thing, although you are not required to basically go for this derivation, but this was just for your general knowledge, that the assumption of homocydusicity is actually assuming something regarding this, right? Homocydusicity assumes that the variance of the disturbance term u is constant, represented by this sigma square. But because the variance of the disturbance term u and variance of the dependent variable y are one and the same thing according to this derivation, so therefore we say that both of them are actually equal to sigma square. So when we are assuming a constant variance for the disturbance term, we are automatically assuming the same for the dependent variable y. That is one of the reasons why you see over here, although the assumption of homoscedasticity is for the disturbance term, but as you can see here, we are actually using that assumption for the dependent variable y. So if you are wondering कि ये y के मुतालिक ये कहाँ से आ गया, so actually this was the reason that I just gave you this idea that variance of u and variance of y, they are both the same, which is equal to sigma square. So therefore, the original assumption says that as x increases, variance of u would remain constant, which ultimately means variance of y would remain constant. But when this assumption is violated, then we have a situation like this, right? So therefore, heteroscedasticity says that as x increases or decreases, the variance of the disturbance term, or ultimately the variance of the y variable, would not remain same. It would change. In this case, it is increasing, but in some other cases, it may be decreasing. What would be that other example? Let me show you this particular example, okay? Like for example, if you, this is a very old example, but it will just give you the idea. Now this is opposite to this situation. In the example where y is saving and x is income, the variance of y is actually increasing as x increases. So we say that there is heteroscedasticity. But for example, if x is hours of typing practice and y is the typing error, right? So when the typing practice are at a lower level, the variations in typing errors is much larger. But as the number of hours of typing practice increases, the variation in typing errors is also is actually decreasing. So in this case also, the variance of the disturbance term and ultimately the variance of the dependent variable y does not remain constant, but in this case it is decreasing, right? So in both cases, we say that we have a problem of heteroscedasticity, right? So the purpose of these two examples is just to tell you that our original assumption actually assumes that the variance should remain constant. And under this constant variance assumption, we get some standard results for our regression model. But now we discover that it's not necessary in real life that this constant variance assumption may be holding. As you can see from these two examples, that it's quite clear that the variance would be either increasing or decreasing. Although we may not always be sure about every situation, that's why we test our model for heteroscedasticity, right? But you should be very clear that there would be situations where the variance may not remain constant, okay? So what would be the problem? Before we can just discuss, for example, how can you detect this heteroscedasticity? Let me tell you something about the problems. We have less than 1 minute left. So I think we should wait and reconnect. इस तरह कर लें? Because number one, you should know why this heteroscedasticity should be considered as a problem for econometric model. एक तो आपको ये clear होना चाहिए. And the next thing is, how can you know that this problem is there in your model? Okay. And then in the last, we would consider solution. तो अभी तक तो हमने सिर्फ इसके meaning देखी है ना? Okay, what is heteroscedasticity? It is violation of the basic assumption, and it refers to changing variance situation rather than constant variance situation. नेक्स्ट हमने ये डिस्कस करना है कि व्हाट आर द प्रॉब्लम्स if heteroscedasticity is there, and number 2, how can you detect it, and number 3,